Isosceles triangle. A triangle is isosceles if it has at least two congruent sides. In the picture that we see here to the right, we do have at least two sides that are congruent because they have the double markings that indicate so. These two sides are congruent. The third side, it could technically be congruent, and we call this an isosceles triangle. However, if the third side was congruent, we would probably call this an equilateral triangle. Okay, so the two sides that are congruent, those are going to get referred to as the legs. The other side is going to be called the base, assuming that that side would be a different length than the other two that we have. The angles that we have at the end of the base, which would be across from the congruent legs, those are going to be called the base angles. The third angle up here at the top is going to be called the vertex angle. That'll be between the two legs of the triangle. All right, so the base angles theorem. The base angles theorem states that the base angles of an isosceles triangle are congruent. They are congruent. See, if you take a look at the picture here, these two sides are congruent. You've got that base that's right there. You could sort of imagine dividing this in half, and you would end up getting a line of symmetry. The two sides would be the same. And if you were to fold that triangle over that line of symmetry, the two base angles would match up to each other, which would mean that they are congruent. All right, so this is a theorem, and what we are going to do here is prove it, and that proof is going to be based off of that idea that we could draw a line right here, split it into two triangles. We could split it into two triangles and then show that corresponding parts, which would be the base angles, we could show that the corresponding parts are congruent to each other. All right, so what we have here is a triangle, which we're going to call JKL. We don't have it labeled yet. JK is going to be congruent to JL. So that means that these will be the legs of the triangle. All right, and both of those use J, so that means that the vertex is going to be J. The vertex angle is J. So we got JK, and the other side would be JL. All right, so these two are going to be congruent to each other. We'll go ahead and add some markings just to make sure that we show that. The angles that we want to prove are congruent are going to be K and L. These are the base angles. We want to prove that those two are congruent to each other. All right, so the way that we're going to do this, we're going to divide our triangle up. We're going to draw a line right down the middle, which is going to divide it evenly. All right, and when we do that, we're going to make a rule about how we do it. Okay, we're not just going to draw a line and say we drew one down the middle. We have to be a little bit more specific. So what I'm going to say is that this line that we're drawing, let's go ahead and give it a point at the bottom. Let's just call it P. All right, so we're going to draw from J to P. What we're going to say is that when we draw JP, we're going to bisect the vertex angle. We're going to force that to happen so that this angle right here and this one, that those end up being congruent to each other. Okay, so we're going to force that to happen. It's going to end up that this is perpendicular. I want to highlight that point there. But the way that I'm going to set up this proof is I'm going to force JP to be a bisector of angle J that we have up there. And if we do that, we'll have enough information to use a triangle shortcut to prove that these two are congruent. We've already got the leg lengths, which are congruent. That was from the beginning. We've got the angle measurements up here because I set that to be a bisector. And JP itself is a shared line between the two of them, so that would use the reflexive property. All right, all we need to do now is go ahead and formally write this up as a proof. So step one is our given information that JK is congruent to JL. Okay, that would be given. All right, and then step two, what I'm going to do is draw that segment, right? I'm going to draw JP. Let's write it this way. I'm going to draw JP as an angle bisector. I'm going to draw that as an angle bisector. All right, the reason for that, we actually just call it an auxiliary line. That's the term for it. Step three, okay, step three, I'm going to go ahead and acknowledge that these two angles are congruent. So I'm going to say that angle JP, or sorry, angle KJP, that'd be this one, is going to be congruent to LJP, to angle LJP. All right, and that's because we have an angle bisector. We have that. All right, so we've got some sides, we've got an angle. Step four, we've got the reflexive side here. JP is congruent to JP, reflexive property. All right, and all of that's going to lead us to say that step 5, these two triangles are congruent. All right, that would be a side link there. All right, so triangle KJP is going to be congruent to triangle LJP because of side angle side. All right, and that almost gets us there. What we need to do is prove that K is congruent to L. We got to prove that those base angles are congruent. All right, so we got one more step here, which is 6. We can now say that angle K is congruent to angle L because of corresponding parts of congruent triangles. Example 1, the base of an isosceles triangle XYZ is YZ. What can you prove? Select all that apply. All right, so we have a bunch of different options here of things that could be congruent, all depending on the picture that they are describing to us here. All right, so let's go ahead and sketch it up. It doesn't have to be perfect, but what we'll go ahead and do is attempt to make it look like there's two sides that are congruent, because an isosceles triangle has at least 2 congruent sides. We don't know if all 3 of them are. All right, the base is going to be YZ. So that would be Y and that'd be Z, or flip-flopped, which means that X is going to be up here. All right, and if this is the base, these have to be the legs. Okay, so these are definitely congruent to each other. In addition, the angles that would be across from the legs, the base angles, those would be congruent as well. So I can go ahead and mark that. Things I don't know the measure of this angle. Also don't know the measurement of the base. I don't know if that is congruent to the others, though it could be. All right, so let's see what we have. XY is congruent to XZ. Yep, those would be the leg lengths, so that would be true. We could prove that. That's pretty much the definition. All right, B, angle X is congruent to angle Y. Can't prove that one. X is going to be the vertex angle. Angle Y is going to be one of the base angles, so we don't know if those are actually congruent. They could be, but we don't know that. C, angle Y is congruent to Z. That would be true because those are the base angles, absolutely. All right, and D, YZ, the base, that would be congruent to ZX. Can't prove that one either. All right, so you can prove these. These would be the leg lengths that are congruent. This would be the base angles that are congruent. Example 2, the lengths of the sides of a triangle are 3t, 5t minus 12, and t plus 20. Find the values of t that make the triangle isosceles. All right, so this is an interesting question because we've got all 3 sides of a triangle being described, right? Let's just suppose, quick sketch here, we'll label everything. We got a 3t, we've got 5t minus 12, we've also got t plus 20. We've got these 3 different side lengths. All right, for this to be isosceles, at least 2 of the sides need to be congruent. So we actually have to look at 3 different cases. It could be these 2 are congruent, it could be that these 2 are congruent, or it could be that these 2 are congruent. So we really just have 3 problems that we have to figure out. Let's start with these 2. All right, so first option, 3t could be equal to 5t minus 12. Could be equal to that. Subtract 3t, you get 0 is equal to 2t minus 12. That means that 12 is equal to 2t. So t could be 6. That could be an answer. However, it might be these 2 that are congruent. So we could have 5t minus 12 is equal to t plus 20. Okay, we'll go ahead and subtract a t. You get 4t minus 12 is equal to 20. 4t is going to equal 32. Divide that by 4, and t is equal to 8. So we could have that as an answer. And we can also look at maybe 3t being equal to t plus 20. Okay, subtract a t. 2t is equal to 20. T is equal to 10. All right, any of those could actually work out. Okay, just we don't know which sides are actually going to be congruent to each other.
Wait, what?